Okay, students, see here, question number 20. In this question, we have a function of x as log of sine cube x multiplied to cos raised to 4x multiplied to x square minus 1, the whole raised to 5. To differentiate this, I write it as equal to y. I want to know from you all, should I differentiate this function of x as it is at this very step? Should I differentiate this function at this very step? See, my question is, should I differentiate? I did not ask you, can I differentiate? Now, the difference between these questions is, yes, I can differentiate, but I should not differentiate. Why? For the same reason. Say, if I differentiate it as it is at this very step, what will happen? I will have d by dx of y, and this side I will have d by dx of log of sine cube x multiplied to cos raised to 4x multiplied to x square minus 1 the whole raised to 5. Now to differentiate this, I need to apply the proper result, and then I will ask you what result is this. I will ask you what result is this. That is, what function is this? Recognize the function. This is always the step. The very first step is recognizing the function. Unless you do this, you will not be able to differentiate it properly. So when I ask you recognize the function is log of f of x. See, logarithmic function, but the variable is f of x. So its derivative will be, as you all know, the derivative will be 1 upon f of x. You can check here, 1 upon f of x into d by dx of f of x, d by dx of f of x. So the reason for which I forbid you to differentiate at this very step is this. You can check what's happening here. Because you differentiated there itself, you are getting d by dx of u, v, and w. See, these are different functions of x multiplied. d by dx of u, v, w. I have already given you the derivative of u, v, and w. If you remember this result we have done, derivative of u, v, and w. So what is d by dx of u, v, w? You will write here this. This thing will be copied as it is. 1 bracket, 2 bracket, 3 bracket, these for these three factors. Then here you will put a big bracket, because you know when you are going for d by dx of u, v, w, d by dx of u, v, w, it is equal to u, v, d by dx of w plus uw d by dx of v plus vw d by dx of u. You go for this. So the same thing here will happen. See, 2 brackets d by dx of w, this one. You understand? Then another 2 brackets d by dx of this one, cos raised to 4x. Then another 2 brackets and d by dx of, you check this, and then you will sine cube x, and then here you have x square minus 1. Oh, see, this is how big it gets, you know. It is not impossible to solve this, but then why? If we can simplify it, we should simplify it. See, we can simplify the given function, because we have got log of m into n into p. We know d I'm sorry, we know log of m into n is log of m plus log of n. So if we have log of m into n into p, if we have log of m into n into p, log m and p if we have log of m into n into p, it will be log m plus log n plus log p. So in short, what we will do, we will not differentiate here this one directly, because if we do that, it gets much bigger. So we should be doing something like this. Okay, give me 2 seconds, I will rub this off all this. So what should we do here, students? I will write here log of m and p will be log of m, that is log of sine cube x. You know sine cube x is this, sine x the whole cube. Then plus log of cos raised to 4x, that is cos x the whole raised to 4, plus log of x square minus 1 raised to 5. So the next step, it will become 3 log sine x plus 4. You know, this is logarithmic rule. 3 is power of m, log of m raised to n, so n log m, and then 4 log of cos x plus 5 log of x square minus 1. And here I decide, see, now this has become the product. What's the gain here? The gain is the product is now converted into sum. The product is now converted into sum. What more? The power has become the coefficient. The power has become coefficient. So product converts to sum, it becomes simplified. The power becomes coefficient, again simplified. Next step is I will write differentiating. Now here I differentiate with respect to x. Differentiating with respect to x. So I will get d by dx of y equals to d by dx of this whole thing, which is 3 log of sine x plus 4 log of cos x plus 5 log of x square minus 1. 5 log of x square minus 1. So you know now you will write d by dx of all this. It is, these functions are added. So you will write separate derivative of for all. So when you write separate derivative for all, d by dx of 3 log sine x, what will happen? 3 is a constant. 3 is a constant. 3 is a constant, so 3 will go out. D by dx of log sine x, 1 upon sine x into d by dx of sine x, which is cos x, plus d by dx of 4 log cos x, that is 4, and d by dx of log cos x, 4 is a constant outside, d by dx of 4 log cos x. So it is 1 upon cos x into d by dx of cos x, that is minus sine x, plus 5 d by dx of log x square minus 1 is 1 upon x square minus 1 into d by dx of x square minus 1, which is 2x minus 0. So you have 3 cot x minus 4 tan x plus 10x over x square minus 1. This is the final answer. This is final answer. Okay, see the video again and try to understand what I am saying.